Welcome to the second week of our virtual forum series on climate adaptation in megacities. In this week, we'll be talking about typhoons, storms, and also weather warning services. And we're going to have two presentations. The first presentation will be on typhoons and storms. The speaker will be Professor Liang Ming Mo. Professor Liang is the former Assistant Director of Hong Kong Observatory and also adjunct professor in Hong Kong Polytechnic University, as well as the Chinese University of Hong Kong. The second presentation will be on weather warning services in Hong Kong. The speaker will be Mr. Armstrong Chen. Mr. Chen is currently Assistant Director on Forecasting and Warning Services in Hong Kong Observatory, Hong Kong SL Government. And let's get started to learn from them.
Hello, everyone. My topic for sharing today is Tropical Cyclones version 2000XX. 2000XX means some time in the future. But at the very beginning, I'll kind of describe the observed trend in the past. And with that as a foundation or the background, then we can go on to find out how climate change and global warming is going to affect tropical cyclones. So someone from the UK Meteorological Office some time ago said that global warming is nebulous. When we talk about global warming, it's kind of a fuzzy idea. But when we talk about hurricane or surviving a drought, then the image becomes much more dramatic and vivid. So we're going to talk about hurricane or typhoon today. All right, this graph here gives you a background of research done by the best scientists in the world. They come to meetings every 2 or 3 years, what they call the World Meteorological Organization International Workshop on Tropical Cyclone, IWTC. And IWTC 10 is the last such meeting where all the experts, all the typhoon experts come together. Okay, now this 3 graphs here is describe the observed trend in the proportion of major tropical cyclones. So we are not talking about tropical depression or even tropical storm. We're talking about typhoons, severe typhoon, even super typhoon. So the chart on the left-hand side is that of the whole world. So for the past 40 years or so, we can see a significant rising trend in the proportion of major tropical cyclones, not necessarily the entire number of tropical cyclones, but the proportion increases. So, for example, if we have 100 tropical cyclones in a year, in the past we might have 10 super typhoon. Now we could have 15 or so, and things like that. So this is the global picture. We have more and more intense typhoon as far as the proportion is concerned. But of all the typhoon basins, we have North Atlantic, we have the Pacific, we have the Indian Ocean, and also those in the Southern Hemisphere. Of all the typhoon basins, the North Atlantic is the basin which see the most rapid increase in the proportion of major tropical cyclones. So the number of major tropical cyclones in the Atlantic basin is getting more and more. If we remove that, remove the North Atlantic from the global picture, then we get the number or the proportion of major tropical cyclones in other parts of the world, not including the North Atlantic. There's still a rising trend, though the trend is not as significant as that in the North Atlantic. So all in all, we are seeing more major tropical cyclones worldwide, particularly in the North Atlantic. All right, this graph here is also extracted from the same workshop, IWTC 10, 2 years ago. Now, this is even more closer to our interest because we're talking about significant size cyclones or tropical cyclones which come close to land. Okay, if we have a very strong typhoon which doesn't make landfall, then probably it don't affect us too much. But if we have a very strong typhoon which landed, then a lot of people will be killed and a lot of damages will be inflicted. So this graph is a lifetime maximum intensity of a typhoon. So what does that mean? When tropical cyclones is very much like a human being. When it is given birth, it is relatively weak. And then as it grows, it becomes stronger and stronger, wind speed pick up and so forth and so on. And then after making landfall, it gradually dies. So this is just like a life cycle. And within that life cycle of several days, there is a certain period of time where it attained its maximum intensity. This is what we call the LMI, lifetime maximum intensity. So this graph simply shows that for a severe typhoons or severe tropical cyclone, when it attained the maximum intensity during the past 40 years, it tends to come closer to the coast. So this is a distance to land. So it comes closer to the coast. And then secondly, for this graph, it is the proportion of tropical cyclones entering the coastal region. By coastal region, it is 200 km. So when it comes within 200 km, then it enters the coastal region. Take, for instance, in Hong Kong, if we have a severe typhoon or super typhoon came to within 200 km of Hong Kong, then very, very likely we need to hoist the number 8 signal, the gale and storm force signal. And then finally, this chart is a total time fraction of the annual mean lifetime spent in coastal region. So we are seeing, typhoons spend maybe 10 days or 8 days in its whole life span. But the percentage of time which a typhoon spends near the coastal region increases with time. So all these three graphs simply tell us that typhoons are disrupting our daily life and also causing damage and also even casualties during more and more during the past 40 years or so. Now this one is even more important because it describes the landfalling typhoons. If we, again, as we said, if we have a strong typhoon, it doesn't make landfall, then we don't concern about that too much. But if we have a strong typhoon and it make landfall somewhere, maybe along the China coast, then it is something that we're really concerned about. So the first graph here is the landfall count, the number of typhoons that actually landed in a certain continent or in a certain continent within a year. So we can see that there is a significant rise from around 4 to maybe around 7. So that is a significant trend of increasing trend, right? TD here means that the time it takes for the number of landfalling typhoons to be doubled. So within a span of something like 46 hours, we can see twice the amount of severe typhoons making landfall somewhere in the world, right? And also for this graph is similar, but not for landfalling typhoons, it's for all significant typhoons. So again, it is a rising trend. Well, so we have more significant cyclones affecting nearly every part of the whole world. Now, we're now focusing, zooming in to the South China Sea. So this is a study published quite some time ago in Nature Geoscience. It's about tropical cyclones in the South China Sea. So this graph, this map shows the path of those tropical cyclones entering the South China Sea, and some of them make landfall over China, some of them make landfall over Vietnam. Obviously, there are some typhoons, tropical cyclone over there, but it's not included in this chart, in this study. Okay, so the right-hand side, this is very, very interesting. The peak intensity of all these tropical cyclones over about approximately 40 years, the peak intensity is increasing. So we are getting stronger and stronger typhoons in the South China Sea and the coastal region. And then the lower part of this graph is the intensification rate. How much a typhoon intensify or strengthen within 6 hours in terms of meter per second. Again, we are seeing intensification rate increases, which is sometimes what we call rapid intensification or even explosive intensification. As a matter of fact, I think we have seen one explosive development in the South China Sea this year in 2024. I'm going to describe that later on. Here is another study carried out in Chinese University of Hong Kong. It's basically a study using computer simulation. The simulation involved two parts. Using the computer model to study 20 significant typhoons which entered the South China Sea and landed very near Hong Kong, 20 of those, okay? And then they do another computer simulation, this time including the factor of climate change and global warming. So they're going to find out what is the effect of climate change and global warming to the same 20 significant typhoons in the past if we add the elements of global warming in the future, all right? So the conclusion of this study is that when we have global warming, the intensity of typhoons will increase by 2 meters per second per decade, which is about 7%. So this is also very significant. Storm sizes will increase under a warmer atmosphere. Now, this is very important. If you remember in 2018, we have Super Typhoon Mangkhut. Well, when it actually comes to Hong Kong, it is not that strong, but nevertheless, it inflicted a lot of damage. 60,000 trees were blown off. And that is because of the large storm size. We have extensive storm surge and flooding, and that is also because of the large storm size of Super Typhoon Mangkhut. So this study showed that for RCP 8.5, which is the worst case scenario of global warming, if we do very little to stop global warming, then storm surge height for some of those 20 tropical cyclones could increase by 40 centimeters. So 40 centimeters is not trivial. Now, we have to be careful that this 40 centimeters does not include the sea level rise as a result of global warming. We have more melting of Arctic sea ice, we have more melting of Greenland ice sheet, Antarctic ice sheet, and also the ocean water is going to expand. So that will give an additional rise in that sea level. So with these two factors, we are going to see a higher frequency of storm flooding in Hong Kong, and also the intensity is going to be more severe. And then another finding of this study is that the vortex, all right, the rotating system, will be sustained for a longer period of time over land. We have some examples for that later on. And then obviously they can travel a longer distance by something like 100 km. Now, this is an interesting study several years ago. In 2013, we have a super typhoon Haiyan, which made landfall over the central part of the Philippines, killing thousands and perhaps even tens of thousands of people in the Philippines, all right? So the black line, that solid line here, is the actual rise in sea level as a result of the approach of the super typhoon. So something like 5 meters. Now, this is the actual measurement. But if in the future, the climate change scenario is that of RCP 8.5, which, as I said, the worst case scenario, the same storm can cause a rise in sea level by 2 meters more. So you can imagine if nothing is going to change and the sea level is rise by an additional 2 meters, then a lot more people will be killed as a result of this super typhoon. Now, so storm surge, wind speed are obviously the very important parameters that inflict damage and casualty as far as a typhoon is concerned. And then another parameter, which is also equally important, is the rainfall brought by tropical cyclones. Now, the graph on the left-hand side is the series of hourly rainfall record in the Hong Kong Observatory, 140 years of data. Right? In the old days, we see that 88.4 millimeter per hour is a record that lasted exactly 40 years. And then after exactly 40 years, another record was broken. And as time goes on, we found that the frequency with which the record was broken increases, and also the magnitude of the increase of rainfall also increases. And this is the latest record, right? Which is which was made in last year, 2023, 58.1 millimeter per hour. And as a matter of fact, over most part of Hong Kong, we recorded more than 500 to 600 millimeters of rainfall in a span of 24 hours. So we have a lot of damages, tons and tons of boulders rolled down from the hillside in the eastern part of Hong Kong. Luckily, no one was killed, and a lot of extensive flooding. Now, this rainfall record is not because of what we call the trough or low pressure or Mayu trough in the southern China. It's because of a typhoon we called Hai Kui. Hai Kui actually not came to Hong Kong directly. It made landfall in Taiwan here, and then traverses to the southern part of Fujian. And that is remnant. It didn't die after making landfall. It travels hundreds of kilometers. And this remnant of Typhoon Hai Kui brought a lot of rainfall. As a matter of fact, torrential rainfall, and causing a lot of damages in Hong Kong. And then we have another case where we just mentioned about global warming can cause rapid intensification. We have just one example earlier this month in September 2024, and that was Super Typhoon Yagi. Now, this is a satellite picture of Super Typhoon Yagi. It is quite distant from Hong Kong, so the impact to Hong Kong is pretty small. But when it makes landfall to Hainan, it is very damaging. And also when it landfalled in Vietnam, kills a lot of people and so on. Now, this graph is the estimated wind speed or intensity of Typhoon Yagi during its passage in the South China Sea. Look at this yellow line here. On the 4th of September, in the small hours of the 4th of September, it was a severe tropical storm status. But less than 24 hours later, it reaches super typhoon status. So an increase of wind speed of something like 80 km per hour within less than 24 hours. And that is what we call rapid or even explosive intensification of tropical cyclones. All right, so this case of Super Typhoon Yagi is in agreement with all those studies carried out by tropical cyclone scientists in the past. And one of the reasons of that rapid intensification is the high sea surface temperature. Well, you know that this graph here represents trend of sea surface temperature in the past 40-something years. So all this line represent 1 year of sea surface temperature. Of particular interest is this red line here, and also this line here, which represent 2023 and also 2024. If you notice, if you study this two curves closely, you will find that starting somewhere from here, all records were broken, right, in the 2023, somewhere around April and May. And then records continue to be broken for many, many months. Okay, so we have record high sea surface temperature for many, many months. And this is a sea surface temperature anomaly in August 2024. So we have very warm water over the South China Sea, and of course also warm water in what we call the warm pool over the Western Pacific. So the rapid intensification of Super Typhoon Yagi, part of the reason is because of the very warm water there. Another reason has been active cross-equatorial flow all the way from the southern hemisphere. And then we have supply of moisture from Bay of Bengal. And then lastly, weak vertical wind shear. This all contribute to the rapid intensification of Super Typhoon Yagi. Well, things just not happened. I mean, this kind of rapid intensification, lots of rainfalls, severe storm surge, not just happened in our region. In late September this year, we just have Hurricane Helene, which threatens unsurvivable storm surge, as forecast by the NOAA, all right, by the U.S. authority. So this is a chart of expected storm surge. So you have 4 to 5 feet over there, 10 to 15 feet, and also most significantly 15 to 20 feet. This has to do with the shape of the coastline. If it is concave, then you can have a larger, larger storm surges. So this is very, very significant. If it does materialize, then a lot of damages will be inflicted. Therefore, hundreds of thousands of people have to be evacuated for this hurricane. Now, if we want to quantify the damaging or destructive power of a typhoon or hurricane, we can use an index called the PDI, what we call the Power Dissipation Index. It is actually an integration over the entire lifetime of a tropical cyclone with the very important parameter of the maximum velocity to the power 3. So the stronger the typhoon, if you multiply it again and again, then we get the largest power dissipation and the largest destructive power. So over the North Atlantic, the trend is pretty clear, okay? The power dissipation or the destructive potential is increasing with time. And this graph here to the right is about what happens in the Western North Pacific. You can roughly divide this 40-year period into two halves. In the first half, which is from 1980 to before the year 2000, there is a mild increase in the destructive potential of typhoons in our area, but very, very, very mild. But then starting somewhere around the year 2000, we see significant rise in the destructive potential of typhoons in our area. So this is something we call a regime shift, right? For many reasons, probably because of intensification of global warming and other factors as well. So similar to the North Atlantic, we are seeing more and more destructive typhoons in our area. Now, this is probably my last slide here. Nowadays, because with advance of computing power and advance of models, in particular climate models and models used for diagnosis, every time when we have a severe tropical cyclone inflicting a lot of damages to other parts of the world, then scientists can quickly run the model to find out, for example, if there is no climate change. Will that typhoon or tropical cyclone be as intense and bring more rain, such amount of rainfall to the area being affected? And then the scientists can run the model again, this time with the parameters of the actual occurrence of global warming and climate change. So with these two run of the computer models, we can quantify, right? We can quantify how much climate change has done to the same natural phenomenon. So here we have three examples. One example occurred 2 years ago in Africa. We have a couple of cyclones. This one is one of those. It passes through Madagascar and causes a lot of rainfall. Most of the damages to this region here is a result of increased rainfall. So the attribution study, which is study using computer models, said that the climate change together with aerosol emission, which is basically pollution, increases the rainfall associated with tropical cyclones. Okay, so this one, Typhoon Gami, which occurred over the Western Pacific and passes through Taiwan and eventually landed over China in Fujian, and then traverses more than 1,000 kilometers. Right, so this is again a manifestation of the fact that typhoons can now travel much further inland and bring in a lot more damages than typhoons in the past. So the attribution study for this Typhoon Gami, is that the extreme winds of this typhoon increased by 50% as a result of climate change. And this study was carried out by Imperial College of UK. Okay, and then lastly, for this one, which is the very infamous typhoon which affected Japan in August 2024, because it basically traverses from west to east of Japan, so causing a lot of landslides, cause a lot of people were killed and so on. So again, the same attribution study carried out by Imperial College suggests that Typhoon Shanshan was made 7.5% more intense and 1/4 more likely as a result of climate change. So with this, I can draw a quick conclusion. Well, in the past 40 years or so, we are seeing larger proportions of strong typhoons, and those strong typhoons tend to come closer to the land and therefore causing extensive damage, not just to South China Sea, but also to the other parts of the world. So to conclude, in our region, the Western North Pacific and also the South China Sea, 2024 seems to be a relatively quiet period as far as tropical cyclone is concerned. But this is not an indication of what is installed for us in the future. As a matter of fact, according to the volumes and volumes of study carried out by tropical cyclone experts and scientists, we are going to see more intense typhoons, more typhoons making landfall, carrying more rainfall, with them carrying a stronger wind speed and also more destructive powers. So the final conclusion is that we have to be prepared for this adverse weather, and also at the same time, we have to do climate mitigation. That is, reduce carbon dioxide emission as fast as possible. Thank you.
Ladies and gentlemen, I am Armstrong Chen of the Hong Kong Observatory. I am pleased to deliver a talk on weather warning services in Hong Kong today. We are living in the Earth with changing climate that poses increasing risk to lives. Launched in 2022 by United Nations Secretary-General Antonio Guterres, Early Warning for All is a groundbreaking initiative to ensure that everyone on Earth is protected from hazardous weather, water, or climate events through life-saving early warning system by the end of 2027. Early warning systems are urgently needed as climate change is causing more frequent and intense extreme weather events, resulting in widespread adverse impacts and related losses and damages to nature and people. Early warning systems are a proven, efficient, and cost-effective way to save lives and jobs, land and infrastructure, and support long-term sustainability. The Early Warning for All initiative is built on 4 pillars to deliver effective and inclusive multi-hazard early warning systems. The delivery of early warning for all requires scale-up and coordinated investments and action across the 4 essential pillars of end-to-end, people-centered, multi-hazard early warning systems. Pillar 1, Disaster Risk Knowledge, is about the collection of data in a systematic way and to undertake risk assessments. Pillar 2, Detection, Observation, Monitoring, Analysis and Forecasting, is about the development of hazard monitoring and early warning services. Pillar 3, Warning, Dissemination and Communication, is about the building of national and community response capabilities. Pillar 4, Preparedness and Response Capabilities, is about the communication of risk information and early warnings. These pillars will be discussed when I talk about the early warning services provided by the Hong Kong Observatory. Firstly, let's talk about the climate trends in Hong Kong. The World Meteorological Organization (WMO) is a specialized agency of the United Nations on climate and weather. In March 2024, the WMO announced that 2023 was the hottest year on record by clear margin. Records broken for ocean heat, sea level rise, Antarctic sea ice loss, and glacier retreat. Locally in Hong Kong, all 12 months were warmer than usual in 2023. 2023 was one of the second warmest year on record, since records began in 1884, with the annual mean temperature reaching 24.5 degrees, 1.0 degrees above the climatological normal from 1991 to 2020. When we look at the number of very hot days in Hong Kong, the trend is alarming. A very hot day is defined as the daily maximum temperature at the Hong Kong Observatory being equal to or higher than 33.0 degrees Celsius. The temperature record of the Hong Kong Observatory starts in 1884. Although there was a break during the Second World War, the record lasts more than a century. We could see on this chart that the number of very hot days ranked one of the highest on record in recent years. In addition to very hot days, the number of hot nights in Hong Kong shows a similar alarming trend. Hot nights in Hong Kong is defined as the minimum temperature at the Hong Kong Observatory being equal to or higher than 28.0 degrees Celsius. The number of hot nights is getting more and more in recent years. As we see before, the number of very hot days increases significantly in recent years. In fact, one may have the impression that a day in summer without significant rain is already very hot in recent years. With warmer climate, it was found that the number of extremely hot days, that is maximum temperature equal to or higher than 35.0 degrees Celsius at the Hong Kong Observatory, becomes more frequent. In fact, in 2022, the number of extremely hot days sets a record high of 15 days. Regarding the highest hourly rainfall on record, you can see on this chart that the record stayed at around 100 millimeters for quite some years from 1930 to around year 2000. However, the record was broken again and again since then. In 2006, the record was broken to 115.1 millimeter, then 145.5 millimeter in 2008. In last year 2023, a new record of hourly rainfall at 155.1 millimeter was set. The new record was registered during the black rainstorm on 7th of September. In fact, in addition to a new record for hourly rainfall, new records for 2-hourly rainfall and 12-hourly rainfall were also set last year during the black rainstorm caused by the remnants of tropical cyclone Haikwei. Moreover, in October last year, a total of 369.7 millimeter rainfall was recorded at the observatory headquarters. This sets a new record for daily rainfall for October. Under climate change, the associated hazards are expected to influence us more significantly. Next, I will talk about actions that will be taken against the anticipated hazards. In response to the changing climate, the government of the Hong Kong Special Administrative Region launched new strategies and initiatives to cope with the occurrence of more frequent extreme weather. There are 4 strategies. These include advanced emergency preparedness, enhanced early warning, decisive emergency response, and speedy recovery. In the following, I will talk more about the work of the observatory regarding early warning. These are the warnings operated by the Hong Kong Observatory. The warnings are issued when relevant natural hazard is imminent. The warnings are issued to prompt people for taking actions to mitigate the risk induced by the hazard. Tropical cyclone warnings are issued when a storm is going to or affecting Hong Kong. Signal number 1 is a standby signal. Signal number 3 warns about strong winds, while signal number 8 warns about gale and storm force winds. Signal number 9 will be issued if gale or storm force wind is increasing or expected to increase significantly in strength. Signal number 10 will be issued to warn on hurricane force winds. Rainstorm warning signals are issued when heavy rain is going to or has already been affecting widespread area of the territory. The amber, red, black rainstorm warning signal refer to different intensity of rainfall. Thunderstorm warning is issued for convective weather including thunderstorm, high gust, hail, tornado, and waterspout. The observatory also issued a special announcement on flooding in the northern New Territories as well as the landslip warning. In recent years, localized heavy rain advisory will also be issued to alert people on heavy rain with hourly rainfall rate of 70 millimeters, which is similar to the intensity of black rainstorm but limited to a small area. Similarly, the special landslip advisory is also introduced this year to cater for situations where territory-wide landslip warning is not yet required, but to alert people on the risk of landslip in localized areas. The observatory also operates strong monsoon signal to alert the public on high winds due to monsoon, fire danger warnings to alert the public on fire risk in dry season. Although rather rare, Hong Kong is a coastal city and could be affected by tsunami, and we have the tsunami warning. The remaining are temperature-related warnings. In particular, we are getting hotter and hotter during summers. The very hot weather warning are often issued in summer if there is no significant rain. Therefore, we need something more to alert people on the health impact due to very hot weather. As said before, the number of extremely hot days, that is maximum temperature equal to or higher than 35.0 degrees Celsius at the Hong Kong Observatory headquarters set a record high of 15 days in 2022. In view of this alarming trend, the Hong Kong Observatory launched a new service in 2023 to alert the general public of the potentially high impact of extremely hot weather. Through the My Observatory mobile application, a push notification will be sent extremely hot weather when extremely hot weather is anticipated. People, especially those who are more vulnerable to heat stroke, are advised to be more vigilant to protect themselves or their families, friends against the extreme hot heat. Moreover, the Hong Kong Observatory also worked closely with the Labour Department to facilitate the launch of heat stress at work warning by the Labour Department. In view of the increasingly frequent occurrence of extreme weather, the Hong Kong Observatory also put forward various measures to strengthen public communication during extreme weather. These include the holding of hourly media briefing during the black rainstorm warning signal to brief the public on the latest development of the rainstorm. In addition, two new terms, namely severe rainstorm and exceptionally severe rainstorm, were introduced to describe hourly rainfall rates of 100 mm and 140 mm respectively. These rainfall rates are far higher than the rainfall rate of the black rainstorm warning signal, that is 70 mm per hour. However, many places register rainfall rates of this kind of order of magnitude during the rainfall in September last year. The new terms could help increase the awareness of the general public. Moreover, the observatory also collaborates with other government departments, such as the Geotechnical Engineering Office, to issue special landscape advisory. Hong Kong is a coastal city. There are some low-lying areas that may be prone to flooding. In a study of coastal hazards under climate change and extreme weather, and formulation of improvement measures by the Civil Engineering and Development Department, it has comprehensively reviewed the impacts of storm surges and waves on coastal low-lying or windy locations. The Hong Kong Observatory also provides the forecast of water level in these flood-prone locations to relevant government departments to facilitate the carrying out of mitigation measures against storm surge during the passage of tropical cyclone. Now, let me introduce the continued enhancements of the observatory's various services. Seizing the opportunity of the development in artificial intelligence, AI, the observatory started piloting AI-powered weather prediction model in mid-year last year for reference in preparing weather forecasts and predicting tropical cyclone track. Here are the forecasts of early October last year made by AI model and traditional physical forecast model in late September. One may recall Typhoon Koinu affected us in early October last year. The forecast chart on the left was from AI model, and the one on the right was from traditional physical model. We can see that there was a tropical cyclone forecast by AI model at the South China Sea, but not from traditional physical forecast model. It looks like that the AI model performed better than the traditional model in this case. However, the use of AI model in forecasting is still preliminary. More studies and case reviews will be released before conclusions could be drawn. The Hong Kong Observatory provides a suite of products to support public weather service. These include forecasts up to 9 days ahead. Though the territory of Hong Kong is not very large, there are notably regional differences in weather. In this connection, the observatory provides regional weather forecasts on its websites and mobile application, enabling the users to appreciate the weather at their own locations. Weather forecasts and warnings are also provided to the fishermen and shipping communities. When there is a tropical cyclone nearby, the Hong Kong Observatory will issue forecasts of its track with probabilistic information included. Before weather warnings are issued for significant weather events, the Hong Kong Observatory will also alert people of the change in weather using weather notes articles and special weather tips. To provide early warning to the general public, the key is to draw their attention by providing more information in advance. Usually, weather warnings are issued when the weather-related hazard is imminent. It may not be desirable to issue a warning well before the occurrence of the hazard. Firstly, there are uncertainties. The atmosphere is a chaotic system that cannot be precisely predicted well in advance, even with state-of-the-art computer forecasting system. Secondly, warnings usually trigger actions. If a warning is issued with large uncertainties or even no action is required immediately, people will lose confidence and awareness on the warning. Therefore, the observatory usually makes use of weather notes article to explain to the public when significant weather events to affect Hong Kong is expected several days ahead, with an emphasis on the possible scenarios. Closer to the time, but weather warning may still be a bit too early, special weather tips will be used to alert people. This also serves as a buffer to buy time when it becomes more certain that a warning is required. For the corporate users, the observatory also arranges tropical cyclone outlook briefing twice every month during the TC season. In the briefing, we can explain slightly more about the uncertainties. The briefing has been receiving positive response by the users, as this helps them to plan ahead, even though it is understood that the worst scenario may not materialize. However, people get prepared if the worst scenario unfortunately does happen. For the weather warnings, weather notes, or special weather tips, these need to reach the end users for them to take appropriate actions. Therefore, it is important to find effective means to deliver the information to them reliably. The observatory has been employing the latest technologies to disseminate weather information to users. In the early years, we used radio. On the timeline, we can see in 1928, weather forecasts and typhoon warnings are started broadcasting through the Radio Hong Kong. In fact, in 1927, 1 year before the broadcast on Radio Hong Kong, the observatory started to broadcast the typhoon warnings and weather forecasts by voice via wireless station established at the observatory. In 1985, the observatory set up the dial weather service that played the forecasts and warnings to users through telephone. When the internet era started, the Hong Kong Observatory was one of the pioneering government departments to set up websites. Then in 2010, we launched the mobile application My Observatory, which has become the most popular mobile application from departments of the Hong Kong government. For the following few years, social media became hot. We set up accounts on various platforms to communicate with our users. In 2019, we are one of the first few departments of the Hong Kong government to set up a chatbot. We will also upgrade it with voice function later this year. The mobile application My Observatory is one of the most popular apps used by Hong Kong people. The total number of downloads already exceeds 10 million, even higher than the total population in Hong Kong. As people get used to acquire news information on smartphone, mobile app becomes an important channel to deliver weather warnings to users. The push notification function is also an important tool to allow weather information to be delivered to the general public instantly. The Hong Kong Observatory was also using social media to promote knowledge related to weather and climate science actively. The contents are made in the form of social media posts, video, cartoon, etc., with a view to reaching a wide spectrum of audience to attract their attention. In addition to the general public, the Hong Kong Observatory also provide weather services to government users, special clients such as users from the utilities, transport sectors, as well as users from fishing, marine, as well as aviation communities. When there is major events such as national days, fireworks, etc., the Hong Kong Observatory also made close liaison with relevant parties to support their decision-making related to weather. For key partners, including the government users, the observatory maintains close liaison with them to advise on weather so that proper actions could be taken timely, in particular during extreme weather events. Prompting users to take actions is important when there are warnings in force. However, it is also important to tell people to plan and get prepared well in advance so that action plans are readily in place before the hazards actually happen. In addition, not all users may have the knowledge regarding the proper response during a hazard. Therefore, it may also be necessary to collaborate with users to develop action plans. In view of this, the Hong Kong Observatory set up liaison groups with users from different sectors. We also held meetings with key strategic partners every year before the wet season to review if there were any issues or difficult cases encountered in the past year, and then discuss any potential improvement or service enhancements that may put into effect in the future. Education is essential to improve the preparedness of the communities. Therefore, workshops and seminars are held in collaboration with various parties to raise the awareness and improve the preparedness against extreme weather. This also includes the annual interdepartmental drill on emergency response to flooding. The drill was conducted every year for Tai O, one of the well-known low-lying villages in Hong Kong, before the wet season to allow relevant parties to get used to the procedures and operations in case contingency plan is triggered when flooding is anticipated. Finally, let me talk about a case last year. Super Typhoon Solar was the second strongest tropical cyclone in the South China Sea since the observatory's record began in 1950. During the passage of Super Typhoon Solar, it also necessitated the issuance of Tropical Cyclone Signal Number 10 since Super Typhoon Margaret hitting Hong Kong in 2018. Solar also attracted a lot of attention because it was approaching the first school day of the year when it edged towards the South China coast. Around the end of August, the storm first lingered at the northwest Pacific east of the Philippines. It made an anti-clockwise loop over the sea east of Luzon. At the stage when Solar was still located east of the Luzon, there were uncertainties in its subsequent movements. According to the assessment at that time, it had a higher chance to move towards the vicinity of Taiwan, but it was possible for it to enter the South China Sea heading towards the South China coast, but with a lower chance. Therefore, a Weather Note article was published on the 27th August to explain the uncertainties in its movement. On the 28th of August, the computer model forecast had better consensus that Solar would enter the South China Sea heading towards the South China coast. To alert the general public that tropical cyclone warning signal may be required towards the middle to later parts of the week, a special weather tips message was issued. Through the My Observatory mobile app, the special weather tips message was disseminated by push notification. Thus, the coverage of the message was high. When the storm got closer and it was more certain the storm would pose a threat to Hong Kong, the government held a press conference on 31st August chaired by the Chief Secretary to announce the necessity of Tropical Cyclone Signal Number 8 as well as class suspension on the first school day of the year. The storm eventually made a direct hit to Hong Kong, bringing hurricane mean force to many places of the territory. Flooding was also reported in low-lying areas. Fortunately, the damages brought to Hong Kong by solar were not as bad as those brought by magnitude in 2018. The society recovered quickly after the passage of the storm. Better preparedness of the society did contribute to the quick recovery. That's it for my presentation and sharing today. Thank you very much.